The second type of equation we're working with in this section are radical equations, or equations with roots. The steps that we're going to follow in this case are as follows. First thing we're going to do is isolate the root on one side of the equation. We want to get just a square root or a cube root or whatever it is on the one side of the equation. Then we will raise both sides to the power that cancels or undoes the root. That is, if you have a square root, you will square both sides. If you have a cube root, you will cube both sides. If you have a fifth root, then you raise both sides to the fifth power. The power that cancels that out. We'll solve the equation that's left, and then we must, absolutely must, check. Check your solution to make sure that we have valid answers. The answers to odd roots will always be valid as long as the problem is worked correctly. However, answers of even root problems may not be valid if you get something where you have a root equals a negative number. That's based on the fact that we assume most often that roots are the square root of something or whatever is positive. So that may come up. If we get a square root or a fourth root, sixth root, something like that equals a negative number, you may have an invalid solution in your hand. So you always want to check. All right, for our first example, solve the following radical equation. The square root of 8x minus 17 equals 1. Well, because this is a square root, we're going to raise both sides to the second power. Raising that to the second power, we have 8x minus 17 equals 1. Squaring a square root results in having just the radicand remaining. Now we can solve this by adding 17 to both sides. All right, so we have 8x equals 18, and then we will divide by 8. Divide by 8. So that we have x equals, and that would simplify to 9/4. Now let's check this. Go over here. The square root of 8 times 9/4 minus 17, and I hope that's equal to 1. Well, 8 times 9/4 would be 72 over 4, which should be 18. So this is the square root of 18 minus 17 equals 1. 18 minus 17 is 1, so the square root of 1 is in fact 1, and 9/4 is a valid solution. For our next example, we first need to isolate the radical. What that means in this context is we want this alone. So we'll subtract 9 so that we have the square root of x plus 4 equals minus 9. Now here's what I mean when I say a square root equals a negative number. We'll continue going, but we may end up with an invalid solution. Squaring both sides, that'll be a positive 81 on the right hand side, and that'll be x plus 4. Subtracting 4, we see that x is equal to 77. Now let's check that. Square root of 77 plus 4 plus 9 equals 0. Well, this is 81. The square root of 81 is 9. So 9 plus 9 equals 0. That is not true. This is not a valid solution, and we have no solution. Also known as the empty set. Our next example is not a square root anymore. It is a cube root. So what we will do differently here is instead of raising both sides to the second power, because again a square root is assumed to have a 2 here, we will raise both sides to the third power. The right hand side is negative 125, and the left hand side is 2x minus 3. So if we add 3 to both sides, 2x equals negative 122 dividing by 2 equals negative 61. Now let's check this. We always need to check. So the cube root of would be 2 times negative 61 minus 3 equals negative 5. Well, that would be negative 122 minus 3, negative 125, and that is in fact negative 5. So negative 61 is a valid solution. For our next example, again we need to isolate, but we also have the cube root, so we will subtract 2 first. So we have the cube root of 2x plus 9 equals 6. And we will raise both sides to the third power. We will cube both sides. And 6 to the third power is 216. So we have 2x plus 9. We can subtract 9 from both sides to get 207. And last, dividing by 2, x equals 207 over 2. Now let's check this value before we call it a day. Cube root of 2 times 207 over 2 plus 9 plus 2. We hope we get 8 as a value here. So these two simplifies to be 207. You should notice it seems like we're going in reverse. 207 plus 9, we subtracted 9 earlier, would be 216. And the cube root of that is 6. Oh, but I dropped my 2. So that would be 6 plus 2, or 8. And this is, in fact, a valid solution. Now, for our last example, we have a slight complication. All right, we're going to isolate, and we'll see what happens in a second. We'll isolate our root first by subtracting 4, but we can't combine those. That's an x minus 4, and we have the square root of x minus 2. As we've done previously, we will square both sides, and this is where things go awry, because this is x minus 4, x minus 4. So this is x squared minus 8x plus 16. And on this side we have x minus 2. Now we can't just solve this because it's not a linear equation. We need to get everything on one side and factor. So I'm going to subtract x and also add 2. So that I have x squared, I'm switching the sides as well, minus 9x plus 18 equals 0. Now that does factor as x minus 3, x minus 6. Now we'll set each of those equal to 0 as we did in the previous section. And this is x equals 3 or x equals 6. Now I wish we could say both of those are definitely solutions, but we need to check them to tell. So erase that, and we'll check over here. We have the square root of, I'm going to first start with x equals 3. 3 minus 2 plus 4 equals 3, because that's what our x value is. The square root of 3 minus 2, that would be the square root of 1, so 1 plus 4 equals 3. That is not true. So x equals 3 is not a valid solution. Now x equals 6. We'll try this one out. Hopefully this is better. Square root of 6 minus 2 plus 4 equals our x value, which is 6. So the square root of 6 minus 2, well, that would be the square root of 4, which is 2, which is true. So our only valid solution is x equals 6.